So, we're here to see Stefan Homan complain about the horrors and critiques that he has on Docker and Co. So please give a warm welcome applause to Stefan.
Oh, thank you very much. Now, before we really start, I couldn't help but notice that we are all a little worn down. This is day 4 of Y, and we're probably not all there at this point, including me. I'm actually slightly worried I will not be able to tell a coherent story. We will see how it goes. For all intensive purposes, this is not just a talk, it's also a bit of an experiment. And for this experiment, I will require 2 volunteers from the audience. Who is in need of a little enrichment? Oh, it's quite simple. I do have here 2 tally counters, one white, one black, quite simple. Every time I say container, you press the white one. Every time I say Docker, you advance the black one. So, who's willing? Okay. We have 2 volunteers, I think, in convenient reach. You take the white one. And
this is for container.
This is for container, this is for Docker. Oh, also, you get to keep them. Actually, have you answered? Right, what brought me here? I do have a background in DevOps and SIE. I've done a lot of consulting. Also, I worked in a field that's called industrial IoT, and as times would have it, that would not work without containerisation. Oh, very good. I heard that one. So, in that field, I would do really, really horrible things. Inject workloads into containers that are not meant to be there. I can really hear that. I did not consider that, but whatever. So, for instance, I would have container workloads that would write directly into kernel memory, that would directly work on layer 2 Ethernet. That's something you would usually not see. Most services that are contained are usually quite simple. These were not. That really equipped me to, it forced me to go down into the plumbing layers of Docker and Co. So, getting a bit of a definition here to work on, we do have a habit in the applied side of computer sciences that we end up with definitions that are not really helpful. So containerization is something system level virtualization or application level virtualization. So JVMs would count as containers. I don't know. It's not very helpful. Bad habit. To give you a brief idea how containers came into being, the first thing I would actually consider a containing solution, that would have been changeroot that came in early Unix development. The purpose of it was that you could concurrently keep several versions of a library and compile against it. Changeroot, to explain it really quickly, is basically a wrapper that tells your applications, oh, you're looking for the root file system. That would be over there, I promise. Changeroot is really a convenient solution. It's never been meant to be more than that. So just to give you an example, the way you would break out of a changeroot is that you gain root access, and then you execute changeroot. That is it. The security contexts, they do not really stack, and that will break you out. Now, changeroots, as I mentioned, they have not been meant for security, and mid-90s came, and people had this brilliant idea, how about we use it for security? Not in that sense. It's really been there to isolate honeypots, basically systems that are incredibly easy to hack. The idea has been to study live attacks and analyze them. So that is sort of okay, but still not really safe practice. Now, change root is isolating a process against part of the file system. If you want a proper container solution, you need a little bit more. You need things like ulimit that would limit the amount of CPU cycles you could execute. You would also want to limit the amount of memory one process can take. Ulimit, later rlimit, turned into, at least for Linux, into something called C groups. Those are functions inside the kernel that do limit a process's capabilities. Effectively, what they do is they do provide namespaces. The Linux kernel does not understand containers. There is a structure called containers that is, I believe, related to memory management, not these containers. Now, C groups advanced quite fairly, and the most driving projects have properly been Docker and systemd. Now, that is quite the coincidence if you consider the early development of both these projects. They have been fierce enemies, and to this day I do recall a time where Docker would not accept systemd-related merge requests. Leaving C groups behind a bit. Oh, by the way, they are not the only namespace mechanism in the Linux kernel. You can have several of these on network level. You can differentiate time zones. Process IDs can be mapped. User IDs, GIDs, whatnot. It's gotten quite good at this point. Leaving C groups aside a bit, we have a sort of development over change root that's been jail in FreeBSD. That has been a proper container solution, if you will. It's quite popular until this day. In 2001, we saw something else on Linux. That's been Linux vServers. Those were implemented through an out-of-tree kernel patch that's been a little bit shaky. I think the project is no more, but to give you an idea, there would be a lot of information bleeding in from the host system. If not properly configured, you could overtake memory, you could load and unload kernel modules on the host system, that sort of thing. It's gotten better over time, but ultimately it failed. Linux containers, they are a popular alternative these days. They do use practically the same features. They also rely on C groups, setting them up correctly, and let the heavy lifting basically be done by the Linux kernel. Then, 5 years later, we saw the first release of Docker. Now, that's been, at this point, more than a dozen years of Docker. Podman came in later. We also had systemd nspawn as an alternative solution. That's basically been change root on speed. Interesting mechanism, but I would consider it a bit shaky for productive use. It's fun to toy around with it. So I mentioned containers, or really change root. They were not meant as a security measure. They are also not really a safety measure. Who recognizes what this is? Okay, quite a few. Would you dare execute this on your shell? Okay, no hands. Yeah, that's good. This is a fog bomb written in Bash. It's defining, to unravel it really quick, it's defining a function called colon, and that will be executed in an infinite loop while producing new offsprings of itself. In newer versions of Linux, you would have a fighting chance to recover from this, but there's no guarantee. And it is important to note, Docker will not help you here. It cannot contain this. That one counts. So, further reading, inspired by Docker and its success, which is undeniable. We had a couple of sorry. There's been a couple of efforts spawning off of it. One is the 12-factor app. It's an interesting document describing 12 key points for modern application development. It's not necessarily pinned to cloud applications, but the target audience is quite clear. Do read it. I do think parts of it actually do make sense, and we should follow whatever is applicable. Spawning off the Docker efforts has been the Open Container Initiative that sought to standardize a lot of things around Docker. It is basically 3 key specifications, being how Docker images or OCI images then are supposed to be built, how they are to be propagated, and what was it? Oh yes, the runtime environment. Yes. Also, the OCI is quite strong on its Docker legacy. There are things like I'm going to show later a Docker file. Some tools do actually support container file as a file name instead. That is hit or miss. Do stick to Docker files, please. To top it all off, there's been the Cloud Native Computing Foundation. That is an effort to really bring applications forth that are specifically designed to be run in the cloud and nowhere else. There's also a lot of projects being backed to support this effort, as in there's a lot of technology emerging here. Now, we start with installing Docker. For the longest time, this has been the recommended path, which is to download a shell script from somewhere and basically pipe it into a root shell. This has never been good practice, let's be clear, and this does need to stop. Yes. You can't bring me to do this. I am going to download it, inspect it, and then do what it tells me to do. I'm not going to execute this. This is insane. MariaDB is doing this quite properly. They do offer a repository configurator, so you get a ready-made configuration script tailored to your needs. This is, to be fair, no longer the preferred path. The Docker documentation nowadays does provide more safer alternatives. Still, these convenience scripts, they are horrible mispractice, and we all need to work on it to make this end. Thank you. We haven't finished. There is one key part missing to get Docker really working for us. That is, our current user needs to be able to access the Docker communication channel, which is a Unix domain socket. It's meant to never leave the system, and that is quite for a reason. Docker by default runs as root. You can have rootless Docker these days. Well, it's not painful to set up. If you do this, if you add your user to the Docker group, you will gain access to this control socket, which is really a very inconvenient to use sudo, but still, your system is now effectively compromised. Worst of it all, this very socket is sometimes needed by services that run inside a Docker container. It is the primary mechanism, and oftentimes the only mechanism, for one process to gain any knowledge about adjacent containers running. Now, some may call this a bold design decision. I do have a select choice of words, but it's being a recorded session. Perhaps not. Hi, Mom. let's get a simple hello world running. This is quite forward. The description is quite apt. What we're doing here is we are downloading an image and then executing it. Once we finished executing, that container is immediately going to be deleted. That's what the -rm is doing. There's a bit of a problem here. What is it we are actually pulling here? We do not quite know. Hello world alone, that is an underspecified container name. That is something that should really be docker.io/library/hello world, and :latest, that is a tag that could lead. Tags are really moving targets. They can be reassigned, and I do know some projects where pulling the latest image, the image tagged as latest, would get you something that is like 4 years old. On the problem of what is it we are actually pulling, there's something like the Docker Content Trust model that allows you to sign your images. Who's doing that? Oh. What? One? That is good. That is really good, except you don't. No, what you're assigning here is not the Docker image itself. It is the Docker tag that is signed. That's one way to do it, because it implicitly signs the image as well. Ideally, you would probably be signing both. That is currently not possible. Also, I've seen efforts to promote this. That seems to have failed, and I'm afraid you are proof of that. So no real way to sign your Docker images. And even worse, if you pull images and want to have these signatures verified, there's an extra step involved. Well, part of the dilemma, or solution to the dilemma, has been to create official images, or mark images as being official. That doesn't really mean a lot. There are a lot of images that have been marked or labeled as being official, and you would think they've been endorsed or even created by the original software vendors. No, not really. And well, the official Docker library FAQ does admit that, and well, they do realize their error. They are terribly sorry, and everything is fine. I'm going to need a moment. Let's create a simple Docker image using a Docker file. I have mentioned an issue earlier. The sourcing Docker image is underspecified here. So what would you think? If I executed this twice, would I get the same image as a result? It could be. We can't tell. The build process in Docker is not particularly designed to be deterministic. There's tooling outside of the Docker world that will help you with that. Still, it's a difficult step. The images that come as a result of the build process are expected to be immutable, no longer changed. The immutability, I'll explain later. The thing about Docker files is they do not result really in one giant blob. It is a bit of a tar archive, and this is divided into something called layers. Each step, you may think of a Docker file to be something of a worse make file, fair. There's more to it. Each instruction, as a rule of thumb, in a Docker file will result in one layer being created. The idea really being that they can be reused and shared among several images. In practice, this is working so-so. You do need access to the previous layers, and well, they can be invalidated through several means. Basically, if anything touching a Docker file changes, the image would have to be rebuilt completely. Now that sounds terribly wasteful, and one may wonder, what about green IT? It's not here. One thing I'd like to remark is the label thing. Labels are basically annotations. A lot of objects inside the world of Docker and OCI containers can have them. They are terribly useful. This one has a version string in it. I'd like to draw attention to it. It's something you would usually not see because it reads version 1.0.0-1. Here's a bit of an issue I often encounter. Usually, people will equate the version of a Docker image to the version of the software they try to package. That goes horribly wrong if there are any dependencies you need to update, because then you need to rebuild the container. And in order to do that, you would actually need to create a new software version. So this is the way to go. Please adopt it. Oh, and in general, these labels are namespaced with org.opencontainers. There is a number of these annotations. If you want to improve your Docker images, go through them, fill them out as far as you can, or as you're comfortable with it. It will make them infinitely better, especially in cases of, you have to dissect something. What this image also does is it defines a volume. I said before, Docker images are not meant to be really modified after they have been created. Of course you can if you know where they are stored on the file system. Please don't. You would be a horrible person for doing that. I'm speaking from experience. The idea here really being, if you run something, there are almost certainly going to be some sort of runtime files being created. And if you recreate a container from a container image, those will be lost. So in order to prevent this, you will hopefully define some volumes to store them and keep them out of harm's way. This is basically all the means you have as the author of a Docker image to communicate the needs of the application you package. There's one more. You can define ports you would like to have opened. That can be obeyed or not. This is basically it. One thing about layers, yes. I do have it in good memory. However, I could not find anything to solidify this claim, so treat it as hearsay. The layer name here, that is prefixed. So we can assume that is a hash using SHA-256. Once upon a time, our layer names did not do that. They had no prefix. But they still looked more or less the same, perhaps a bit shorter. Treat it as hearsay, as I said. There used to be random strings. So we have an image. We brought it up running. So we created our container. That is great. What is the application in there doing? Is it doing anything at all? This is a very abbreviated view of Docker on the processes it manages. So it will have a process ID that could be mapped to be something different inside the container. We don't know. If it exited, it could have an exit signal, and hopefully that's going to be 0. And there is one entry point. What I missed in the introduction is there has been 2 schools of thought really emerging here. One is that one container is only good for a single process, and it should contain that. The other is to treat containers more like lightweight virtual machines, which would also mean they would have to be serviced in the same way as a virtual machine or even bare metal system. Now, this is for more complex applications that is sadly not really working out. The idea is actually quite great. If you have every process contained in one container, you get something called compartmentalization. And mind you, that is the technique that almost prevented the Titanic from sinking. Point here not being, oh, that doesn't work. Point being, it needs to be implemented correctly. So this one entry point thing has turned into a bit of a problem because there could be some complex tasks hidden in there, and if that, whatever the entry point is, if that process vanishes, so does your container. So it could be that the fate of your container is tightly connected to that of a very flimsy shell script. There's been a trend as of recent, well, I'm saying as of recent, it's probably been 5-6 years, probably earlier, to let a miniature init system run inside a container. That can't be systemd for a number of reasons. Buy me a beer and I will tell you how to get systemd running in Docker really effortlessly. And to sweeten the deal, I'm also going to tell you why you should never do that. In this place, we often find things like S6, which is coming out of Alpine. Alpine, by the way, started as a bare metal distribution, not a container. It's not being intended for containers, but it turned out it works well for those, so there it is. Do give it a try. Doing interesting stuff. So it's either S6 or something like Tiny that's in it in reverse. Point being, we do have a super daemon running, started by a container runtime, and then being managed by a proper init system. That is quite something. A while ago, we decided that we would have super daemons in user space. Think of the daemon tools and xinod and whatnot. But this is, I'm on the edge. Point being, it's not quite working out. What is really infuriating is we do need to observe the process we are running inside our containers. There are 3 file descriptors predefined. That is very, very Unix. You have a standard input provided, you have a standard output, and you have a standard error. Those are 3 textual streams. Docker will happily accept those, so far so good. They are guaranteed to be there, and it will mesh standard output and standard error into one singular stream. You can't distinct it. Even if you get into the on-disk file format, there's no way to separate these. This is Kubernetes version 1.32 should have been released last month. Anyone knows? Is that accurate? Well, I didn't check. It does have a feature gated to split this up. Configuring containers then. There are 4 main methods. One is to pass environmental variables to them. Still very Unix. One is to modify the entry point set in the Docker file. That's okay. You can use volumes specifically crafted to inject configuration files or configuration fragments into your container. That is also certainly that's okay. And you have the option to provide additional labels. Those will mostly work for the runtime environment. In some cases, I mentioned services running inside containers that would pull information from other services through the Docker socket. That's how it works. Now, if you want to have your configuration somewhat portable, you would offload it into a Docker Compose file that is straight YAML, and that is the most amazing file format ever. You see a version field here. If you execute this, you will get a warning that this has been deprecated for good reason. I mentioned in the introduction I used to do weird things with containers, and I did need some more exotic features, and yes, the version field. The magic about it is if you modify it, you may lose access to some features. Oh, that's quite simple, you may think. Or you change it, perhaps down. No. You advance the version field, and suddenly your Docker Compose is no longer valid. Now, I would like to ask the audience, who of you is inspecting Docker Compose files if they get them from third parties? Okay. That's me. I'll take that answer, yes. Well, I do, because a surprising number of times there's very questionable things in those. I think the most popular are needless opening of ports. That is going to compromise the system. People do not seem to, and the majority, they do not seem to grasp how networking is working inside Docker. So that may lead to issues. All in all, if you have a lot of these, you may be better off using a firewall appliance in front of your host, because things are going to get ugly. Another thing is volumes. We have one volume here specified that is leading with a dot. That tells Docker Compose to create a volume relatively in relation to the position of the Docker Compose file. That as well will get you a warning, and equally with good reason. I still see this a lot. Please stop doing this. Use named volumes. Have volumes at a defined place, not scattered around the file system. It makes it impossible to find a good backup solution. And I see you know what I'm talking about. Also, any security framework you may have in place, they have gotten pretty good these days, but still, it's making things unnecessarily complicated. Do not anger SE Linux. Do not upset GR security. Don't worry about AppArmor. That's always been a bit of a joke. Leaving Docker Compose, we get to Kubernetes. And, well, Kubernetes. There's guidelines for there's guidelines for the accessibility of the slides at Y, and I never had any hopes of getting all of that onto one slide. Who recognizes what that is? Oh, one? Okay. Perhaps someone with above average eyesight. No, okay. This is straight out of the example playbook for Kubernetes. It is configuring 4 containers to be a stateless guest book with a web front end. That alone is quite complex, but when I put this all together, I ended up at, on the spot, 140 lines. That is little. That is tame. What do you see here? These are Kubernetes resource definitions. They often go into the thousands of lines of code. There is really little chance to review this properly. You see the format being all YAML is quite verbose, and you may get ideas like, oh, someone's had a really bad case of Java. This actually makes sense. The way Kubernetes is set up, this makes sense. And some of you are laughing, you do not realize how much you would want this. You don't want to type this. That is a very error-prone process because a lot of it looks quite alike, but there are subtle differences. Don't worry. Your editor of choice now not only gets to understand YAML, it also gets to understand Kubernetes resource definitions. No? Okay. Anyhow, using these, it is actually fun in a weird sense of way because you get to define, say, volumes, of course. You get to define scheduled execution of tasks. All in all, it does feel like configuring an entire operating system, and I do believe Kubernetes fully qualifies as being actually a distributed operating system. So it's been fun. There are many ways to shoot yourself in the foot. It's also not fun to keep it running. Yesterday's talk, Kubernetes the hard way, may have given you an impression. Who saw that? Okay, some. Go see the talk. Amazing. So you do want this. You don't want to type this. That is okay, because you don't need to. There are some templating engines in place for that. The most prominent one being Docker Helm. That is going to generate large chunks of these. Problem being, Docker Helm is often marketed as some point of packaging solution for cloud workloads. That's not really what it does. It is a template engine, somewhat role-playing like a package manager, however, is using Slackware. Oh, no Slack. Oh, okay. Oh, two. Okay. You do know how package management in Slackware works, Yogurt? Okay. Yogurt has this amazing idea that you, as the system administrator, need to be fully aware of what you install. Docker Helm is somewhat working in that direction, except Docker Helm is working on something called Helm charts. They can pull in other Helm charts. If you don't review them, you are set for time, because you cannot just. You see here a version being pinned as 6.05. You cannot blindly just pull the latest image of things. That is a recipe for disaster. Also, there is, I should mention, there is quite a surprising amount of discussion in the nature of Kubernetes resource definitions, because these are all configuration. What are these at the end of the day? I do believe these are installation plans. That is something entirely different. These are not really state descriptions. You cannot delete resources through Kubernetes resource definitions. That is done implicitly if you stop mentioning them. So we can't have this talk without mentioning DevOps a bit, which has been set out to close the gap a bit between development and operations, and in that part to break down silos a bit, spread knowledge. All good and well. There's this ever-repeating mantra of that being a mindset, not a set of technologies, not a set of tools. I'm afraid it's all a lie. No, it is a specialist role using very defined technologies, containers being part of that. And, well, the original DevOps logo has been a simple circle. Someone had the genius idea to bend it into an infinity symbol. Going a bit through the iconography, I thought I'd suggest something else, perhaps. And so you're never going to finish. But I do have to mention, containers, as they are really, really good at process isolation, at nailing down environments. And we do have these in a portable and somewhat recreatable way, meaning we can, in DevOps, get a process running in which we develop, test, and run things in environments that are very, very similar to each other, and that is something we cannot leave under or unappreciated. So, finally, that is the slide where I get to talk a lot. Is it all that bad? Yes, but no. Some of the things I mentioned here, they can be addressed in OCI containers alone because the standards that have been set are quite modular. One thing being the layer system that actually has its uses, actually is a good idea, but these days it's rather doing us a disservice because there's a lot of dead weight basically in it that can't be simply removed. If you're interested there's eStargazer, which implements lazy loading of layers. That's quite interesting. There's an AI approach that works as you would expect. Thing is, a lot of the criticisms I applied here can be actually addressed. However, this does involve some rather painful discussions about OCI containers, and we may have to let go of OCI 1 style containers in the future. That is quite a scary thought, but well, it would cut us off from more than a decade of packaging efforts. But it cannot be. Well, I'm going to address the elephant in the room because the containers have been advertised as being a good packaging solution. They are not. They are a stopgap measure. They've been advertised as being a good security measure. They are great at undermining your system security, actually. They've been advertised as a safety measure. Yeah, well. They are really good at process isolation. That is where they excel, and we should really focus on that. So, that being said, a decade worth of packaging efforts, there's a lot in there that is outright scary. There's been a shift of tone as of recent, and people got more critical about the adoption of containers in their systems, in their workloads. And I think that shift in tone is just enough to help us get this discussion going, which may allow us to succeed in truly containing the horror. I'd like to conclude my talk here. How are we doing time-wise? 5 minutes. Okay.
Any questions? Hang on.
So I know that, I mean, we're talking about Docker and, the usual suspects for containerization. Now there's all types of esoteric technologies that are coming up, like micro EMs, Firecracker, Kata containers, all those kind of things. Like, do you have an opinion on those, or they are just the same?
Part of my issue really is that I think that Docker is not very well engineered software. It's getting better at the moment, but the damage has already been done. And there are new solutions coming out that do actually have proper interfaces, and they are working well, such as Flatpaks. They do have a different purpose. Oh, there could be snaps.
I'm off above one. Can you say container one more time?
Container. What was that? I think it's... Is it now a round number? No,
it's 45.
Oh, it's...
Thank you for talking. Do you think isolation will in the future arrive at a point that could rival actual virtual machines?
That's an interesting one. I do think there is always going to be some cross-contamination, if you will, from the host system into containers. At the very least, you will have things like the CPU architecture. You will have things, possibly the CPU serial number. No, I don't think so.
Any other questions? If not, I kindly ask for another. One more question there.
Oh.
Just last minute. Just 2 minutes. So.
Have you ever looked into creating Docker images with Nix, which should fix like 80% of the reproducibility issues, not 100%?
Yeah, that's. I don't think that's unique to Nix. I have looked at it. I have not actually tried it. I'm currently simply lacking the time to get acquainted with Nix, really. It is on my bucket list, though.